Hi, my name is Eric Rudberg, and I'm a fourth-year industrial engineering major at Cal Poly San Luis Obispo. And today I'll be talking about my senior project, which is an efficient concrete delivery system for the company Webcore Builders. So, for a quick overview, I'll be talking about the company background of Webcore Builders, who they are, what they do, what services they provide, problem statement for my senior project, the objectives, the goals that I hope to achieve with the senior project, the outcomes, and all of that, and a literature review of the sources that I used in order to become educated on the subject of concrete and its delivery, the action steps I took for the specific data that I collected, the solutions I came up with based on this data, and the conclusion for which alternative of the three I picked would be the best for Webcore to pursue. So for the quick background on Webcore Builders, they are a commercial construction contractor based in San Francisco, California, though they have locations throughout California. Thousands of people work at this company. Um, some of the services they provide are entitlements, pre-construction, construction, warranty, and building services, but the number one they provide is subcontracting. Some of their values, just reading them off here, are sustainability, treating construction as a craft, innovation, sense of community, and boldness in the face of adversity. So clearly they pride themselves on their work, and also they like to think of their workspace not as just a place where they go to work, but also a community of friends. So quick background on my specific project. First of all, it's important to know about the history of the concrete delivery at Webcore and its placement. So for my project, the specific aspect of concrete delivery is the actual part of the project where the ready mix supplier hands off the concrete to the Webcore concrete group. And this is because there's been a lot of miscommunication in the past about who's responsible for sort of the wasted concrete that occurs as a result of them not showing up at the exact same time. And so it is my responsibility to determine what the Webcore concrete group is responsible for and what the ready mix supplier is responsible for. And so, as I'll go over later, I need to determine a system of metrics for determining um, who's responsible for the inefficiencies that go on with these concrete deliveries. And so some of the risks that this inefficient delivery poses are wasted time, wasted money, and wasted concrete, which is essentially wasted money, but with the added effect of negative ecological impact, because there's a lot of wasted concrete that goes on sometimes in these pours, and that concrete all has to go somewhere. And as I'll go over in my literature review later, this poses some negative environmental impacts. So going over my objectives real quick that I kind of already stated, the goal of this project is to develop a system of metrics to measure the inefficiencies that go on with concrete delivery. Specifically, who's responsible for the inefficiency, and what specific thing caused them to be responsible for the inefficiency, like a miscommunication or like maybe the concrete like dried out or something like that. And what could have been done differently, looking to the future, how they can change what they're currently doing in order to optimize their current processes. So I'm going to read off a couple of these since there's a lot, but some of the data and deliverables that I analyzed for this project are the volume of the concrete pours and the surface area if it's a slab, quantity of the concrete per hour ordered, the mix design, the time of each truck entering and leaving the job site, the start and finish time of each pour. So like when the concrete gets on the job site and when it's actually being used, the lead time in between those two times. Also the quantity of concrete ordered versus the quantity actually used. So how much is being wasted. Any changes to the rate of delivery or total quantity called in during the pour by the Webcore concrete group. The weather, because sometimes the rain can make the concrete moist, or if it's too sunny, that can also affect the texture of the concrete, or even if it's too cold. Any specific admixtures used, any specific logistical constraints. Although, since I was only able to make one site visit, since Webcore is like 4 hours away driving from my school, a lot of the logistical constraints that occur won't really come up during one site visit. So that's something to keep in mind, is that all of these things came up during one site visit. Even though I did have some other data to work with, a lot of it doesn't really pertain to like logistical constraints. And so the pump sizes of each concrete pour and the structural elements of some of the admixtures that were used in the pour itself. So for the literature review, just quick summary, I looked into the variables that affected the project, which would include how the structural integrity of the different materials would affect the pours, the effects of the machinery that do the pouring, though since it's usually the same machines, mainly it was just like comparing the machines that would do the pouring and which systems are better for which types of pours, whether there's effect on each pour, and some of the logistical constraints that I wasn't able to really analyze because I only made one site visit, so this is really compensated for in the literature review. So the solution for the system of metrics is to determine, or to have a system that determines the responsibility of each inefficiency, or mainly the major source of the inefficiencies, because accounting for each and every inefficiency that occurs is practically impossible and really outside the scope of my project. So what I tried to do was focus in on the major sources of inefficiencies. So by doing that, I had to look at the current state of the concrete pours by going to the job site and examining what they're doing right and what they're doing that could be improved. And I had to do this while keeping in mind certain design constraints and requirements. For example, there's a finite amount of concrete, a finite amount of money, and essentially just a finite amount of resources that go into the concrete pour. So all of the solution systems used a Pareto analysis just because it was the most practical for the types of data that I was collecting. So the first one that I performed was on the 5 main causes of waste, which were, and if you look here, these are all different areas at WebCore. So the numbers on the chart are for the amount of things that are the amount of wasted materials that occurred at each specific place. So by analyzing the place of where the inefficiencies occurred, I came up with basically like top 5 areas that are the most prone to wasted materials. The next is budgeting. So essentially, I have it written there, I performed time studies on the processes that involved materials that made up the 5 largest sources of money spent. So basically, I analyzed the data for what 5 processes, pours, consisted of the most money being spent. And so this included the deck, the mat slab, the walls, the columns, and the rat slab. And a quick summary of the alternative solution, or the second alternative solution, is that if you look at the graph here, each x value represents a different concrete pour, and each y value is the amount in dollars. So this is like the total cost of each pour, which is different from the other one because it includes like the truck delivery and all the materials and resources that went into the concrete pour. So this includes literally everything that goes into each pour. And so each number here on the x-axis represents a different concrete pour, which has significance when you actually have like the name of the pour, but that wouldn't just fit on the graph here. It would just take too much time to read anyway. So, but basically you can see that it's actually kind of evenly distributed, but so you can just basically attack the ones that consist for the most money being wasted. And those are like the top 3 or 4. So for a conclusion, which alternative is best? It's really hard to say because one alternative wastes more materials, but another one wastes more money. So it's really up for WebCore to decide. But I can't be the one to judge that. So if they want to be more eco-friendly, that's on them. But anyways, that's the end of my presentation. Thanks for listening. And yeah, have a good day.